Assalamu alaikum and good day to each and everyone. So obviously this is our 8th lecture for this subject, the ES11. Okay, but before I formally start this discussion, again I want to remind you that you better download this file that I have posted in our Edmodo classroom. At the same time, I highly encourage that you better print this file for you to easily cope up while listening or while watching this video discussion. Okay, because this printed handout of yours will serve as an outline of this discussion. Okay, so first things first, let's introduce the topic for this video discussion. So as you can see in here, ang discussion natin dito is about flexible cables. So obviously, yung pag-uusapan natin is yung concept behind flexible cables, yung use ng flexible cables, at the same time, yung analysis on how to solve flexible cables problem. Okay? So, before that, let's read this first paragraph. One important type of structural member is the flexible cable, which is used in suspension bridges, transmission lines, messenger cables for supporting heavy trolley or telephone lines, and many other applications. So as you can see in this first sentence, the use of a flexible cable is to carry loads or to carry heavy loads. And meaning to say, kung makikarry siya ng heavy loads, there is no analysis sa flexible cable na isang compression member. Meaning to say, yung analysis lang sa isang flexible cable is a tensile force or tensile stress. So yun, there is no analysis in flexible cable such as compressive force or compressive stress. So, to design these structures, we must know the relations involving the tension. Yung sabi ko kanina, analysis lang ng flexible cable is tension at walang compression. Span, sag, and length of the cables. So, meaning to say, kung mag-analyze tayo ng problem which involves flexible cable, ang dapat nating malaman is yung relationship ng tension, meaning to say yung tensile force or tensile stress, yung span, meaning to say yung haba ng cable, yung sag, meaning to say yung pagkakasag o yung pagkakasag ng isang cable, at the same time yung length, meaning to say length with respect to its curvative span. So, yun yung pag-analyze ng flexible cable. Ito yung dapat nating malaman, or ito yung dapat nating ma-internalize on how to find the relationships of this. So, we determine these quantities by examining the cable as a body in equilibrium. So, obviously, subject natin is ES11, which is statics of rigid bodies. So, kung mag-analyze tayo ng flexible cable, ang assumption natin dito is in equilibrium, meaning to say, summation of all forces along X, summation of all forces along Y, at saka summation of moment is equal to 0. Okay? So, yun ibig sabihin dyan. In the analysis of flexible cables, we assume that any resistance offered to bending is negligible. So, bending daw is negligible sa flexible cable. This assumption means that the force in the cable is always in the direction of the cable. So, as you can see in here, diba sabi dito, the assumption means that the force in the cable is always in the direction of the cable. Again, take note, always daw nasa direction ng cable yung force. Yung assumption sa flexible cable is yung force daw is always sa direction ng cable, meaning to say towards the cable. So, flexible cables may support a series of distinct concentrated loads. Meaning to say, yung flexible cable daw is kaya nitong mag-support ng concentrated loads. For example, this one sa figure A. Or they may support loads continuously distributed over the length of the cable. This one, the distributed load. Or, as indicated by the variable intensity loading W in the figure 1B. So, this one. So, for further elaboration about this figure 1A and figure 1B, we have these cables with concentrated loads. Yun nga, yung sabi ko kanina, yung cable may carry a load which is concentrated. Concentrated meaning to say pointed. Okay? Tulad nito, pointed meaning to say point load A, point load B, at saka point load 3. Next, or else, yung cable daw is pwedeng mag-carry ng loads which is in distributed loads. Meaning to say this one, which carries a load of, or uniformly load of W. So do not get confused. A cable may carry a pointed load or concentrated load or distributed loads. Okay? Just see the difference. So, next, let's discuss what a parabolic cable is. So guys, or class, sa flexible cables, dalawa always yung analysis natin dyan. It's either parabolic or catenary. Well, in this video discussion or sa handout na ito, ang nandito is parabolic cable. Sa next discussion natin, sa next handout, doon ko gi-provide yung catenary cable. So I hope I am making myself clear. Okay? So sa discussion na ito, ang pag-usapan natin is about parabolic cable. The concept behind parabolic cable and analysis on how to solve parabolic cable problems. So in parabolic cable, when the intensity of a vertical loading W is constant, the condition closely approximates that of a suspension bridge where the uniform weight of the roadway may be expressed by the constant W. The mass of the cable itself is not distributed uniformly with the horizontal, but is relatively small and thus we neglect its weight. For this limiting case, we will prove that the cable hangs in a parabolic arc. So, sa parabolic cable, yung analysis class, yung analysis sa parabolic cable is it carries loads. Aside from its weight, aside from the weight of the cable, nagdadala ng load yung cable. For example, yung suspension bridge, dala ng cable. At the same time, yung mga truck, yung mga sasakyan, nadala ng cable. So, meaning to say, kapag may additional party na ina-analyze natin sa isang cable, that is a parabolic cable. Just a heads up, i-compare natin sa catenary cable. Ang catenary cable, ang gina-carry lang na load ng catenary cable ay ang self-weight nito. Okay? Take note, again, yung parabolic cable, may dala itong additional loads because its own load or the weight of the cable is negligible because of its a relatively small amount. Pero sa catenary cable, ang gina-carry or dala ng catenary cable ay yung self-weight mismo ng cable na yon. Meaning to say, yung bigat ng cable na yon ang gina-analyze natin sa catenary cable. Just please see the difference between the parabolic at saka yung catenary. Okay? If I might ask you again kung ano yung difference ng dalawa. Sa parabolic cable, may dala itong additional loads. Okay? Neglecting its self-weight. Pero, sa catenary cable, ang loads na dala nito is yung self-weight ng cable. Meaning to say, yung sariling bigat ng cable. See for this figure, yung figure 2 na ito, we have this figure, we have this cable, point A at saka point B. As you can see, may dala itong load per unit of horizontal length. For example, this load is actually a rod. So meaning to say, this cable is actually a parabolic cable kasi may dala itong cable or may dala itong weight aside sa self-weight ng cable na ito. I don't know if you can still recall yung sabi ko kanina ng relationship. In this part, yung tension, yung tension, span, sag, at saka yung length of the cables. Yung ibig sabihin dyan, for example, this figure, ito yung class again, yung i-analyze doon natin is yung tension inside this cable. Next is yung span. Yung span, ibig sabihin ng span is this one, from point B to point A, itong dito, yung span. Yung sag is yung yung height ng dalawa ng between 2 points or this certain point. At saka yung pang-apat is yung length. Okay? So, in deriving of the necessary formula obtained from figure 2, we will arrive to the following formulas below. So, these three formulas, itong y is equal to omega x squared over 2TO. At saka yung Tmax is yung pag-analyze ng maximum tension in a certain point. Okay? Is equal to omega L over 2 times the square root of 1 plus L over 4H quantity squared. Yung pangatlo, S is equal to the integration of square root of 1 plus the first derivative of y squared dx. So, itong tatlong formula na ito ay na-derive from this figure. Okay? Pero, take note, Sources of equations in solving parabolic cable problems are as follows. These three sources ay pwede daw i-solve yung cable problems by using these three sources of equations. First is to use the closed polygon method, which is the right triangle. Next is the square property of parabola. Ang formula ng square property of parabola, this is actually common in your geometry or in trigonometry. It's a 4a is equal to x squared over y equals to constant. And third is the integration in solving the length of the cable, which is same lang dito. And by the way, class, I want you to take note this one. I believe you are already done with your general physics, right? Because you cannot proceed in ES 11 not unless you are already done with your general physics. Okay? So, I am saying this because yung concept sa catenary cable, sa parabolic cable ay just the same with projectile. Because sa highest point, for example, this one, kung nasan yung pinaka-highest point, kung saan yung highest point, ay nandoon din yung largest tension, meaning to say the Tmax. This one, di ba? Example natin sa figure 2, sa highest point, nandoon yung Tmax, the maximum tension. In this figure, ang maximum tension is nasa point A. Again, next, yung lowest point has the smallest tension. Meaning to say, kung titingnan natin kung i-analyze natin yung problem na ito, yung figure 2, yung pinakamaliit na tension is nasa point na pinakamababa yung cable. Example is this one. Pero yung weight will act on the center of the loading, not on the cable. Take note, yung weight daw ng center, yung weight daw ng isang object is nasa center ng loading and not on the cable. Meaning to say, kung i-analyze natin itong length from B to A, yung loading daw is nasa center ng yung weight daw is nasa center ng loading at hindi sa center ng cable. Okay? So, that is all for the concept of the parabolic cable. Again, pag-analyze ng parabolic cable is you will start your analysis from the highest point to the lowest point. And if necessary, you need to cut each point. You need to cut a certain point for you to analyze this problem. In this case, i-analyze mo from highest to lowest point. So that is all for the concept of parabolic cable. So in the next video, we will be discussing, or I will provide one example for you to understand more what a parabolic cable is.